Hello students, welcome back. Today's video is going to be a quick summary comparing and contrasting series and parallel circuits. Series circuits are electric circuits where the current can only go through one path. In this picture I have a series circuit with two resistors. The current will simply just flow from the positive end of the battery through the resistors and then return back to the negative end of the battery. If we know what the voltage is, we can calculate this current using Ohm's law. My triangle for Ohm's law looks like this. If I want to find current, I have to cover it up, and I have voltage divided by resistance. If we know that this voltage is 5 volts, then all we need to know is the resistance. For a series circuit, the total resistance is just the sum of the resistances. If I use a 7 ohm resistor here and a 10 ohm resistor here, 7 plus 10 is 17, so my total resistance is 17 ohms. Now to find current, I just have to divide 5 volts by 17 ohms, and this comes out to 0.294 amps. And because the current doesn't split through different paths, this is the current that is constant throughout the entire circuit. This is only the case in a series circuit where current is constant. Because in a parallel circuit, on the other hand, the current diverges at a certain point. Okay, now I'm going to go through like a similar process that I did over here. I'll try to find the current around this parallel circuit. I'm going to say that I still have a 5 volt battery and my resistors are still 7 ohms and 10 ohms. But now they're in parallel with each other. So these calculations are now going to be different. We'll see how these calculations compare side by side between series and parallel. The first thing to take note of is that you need to calculate total resistance differently between the two. In a series circuit, you just add the resistances, but in a parallel circuit, you have to follow this equation. You have to add 1 over the resistance plus 1 over the other resistance, and then put that in parentheses and then take the negative 1 exponent. So in this case, if I want to find the total resistance, I'm going to have to do 1 over 7 ohms plus 1 over 10 ohms in parentheses, and then put the negative 1 exponent after that. Alright, when I put this in my calculator, it comes out to approximately 4.118. Once again, this is the total resistance of the circuit. So if I want to find the total current, or in this case, the current that comes out of the battery or returning into the battery, this is the current before it splits and also after it recombines, so it's the total current. To find the total current, I have to use the total resistance. Okay, so I'm going to use Ohm's law, voltage divided by resistance, my 5 volts divided by 4.118 ohms. So my total current came out to 1.214 amps, and you can see that's a bigger current than it was in the series circuit, where I had the same resistors, but the only difference was that I hooked them up in a different way. If I wanted to, I could also find the currents in each of these branches. Still using Ohm's law, it would just be current is equal to voltage divided by resistance, but in this case, instead of using R total, I would just use R1 and R2 for each branch. Here I made these calculations on the top. I1 is the current of the first branch, which is just 5 volts divided by 7 ohms, which comes out to 0.714 amps. And then for the second branch, it's I2, which equals 5 volts divided by 10 ohms, and that comes out to, of course, 0.5 amps. If I add these two currents, 0.5 plus 0.714, it actually comes out to the total current, 1.214. So here my numbers are consistent, but I can see that in a parallel circuit, my current is not constant, whereas in a series circuit, the current is the same everywhere. Next, I'm just going to quickly list off their different qualities. The first comparison is that in a series circuit, current is constant, while in a parallel circuit, current is not constant. Because in parallel circuits, the current has to split. If you measure the current on those other branches, they're going to be less than the current that comes out of the battery. The next comparison I want to make is that for a series circuit, the voltage is divided between all the resistors, while in a parallel circuit, each branch will receive the same voltage. If I have 2 light bulbs connected in series, they will divide the voltage evenly between them. They will glow a little bit less brightly than if there was just one bulb. Whereas in a parallel circuit, if there's 2 light bulbs connected in parallel, they will each receive the full voltage and they'll both glow brightly. Which is why we use parallel circuits as our electrical systems in our homes. The last comparison I want to make is how to calculate the total resistance. For a series circuit, you just add up the resistances for each resistor, while in a parallel circuit, you use this equation where you add the inverse values of the resistances, or 1 divided by the resistance value. You put that sum in parentheses and then take the negative first exponent. These resistance values are the total resistance, which is the resistance of the entire circuit. That's going to be all for this comparison of series and parallel circuits. Thank you guys. See you next time.